Good morning, everyone, or good afternoon, depending on where you are, and welcome to today's webinar, VMware SD-WAN and Microsoft coming together with Azure M365 and more. Before we begin, you can submit questions through the Q&A panel, so please feel free to use that. We will answer the questions at the end, as well as download any more details about today's webinar topics in the attachments section. Today's session is also recorded and will be available on demand for you to watch afterwards if you so wish. So with those housekeeping items complete, I'd now like to introduce today's speakers. So Tej, would you kindly go first?
Sure. Thanks everyone for joining today's webinar. My name is Tej Prabhat. I'm a Senior Staff Solutions Architect here at VMware. I've been in SD-WAN domain for quite over 5 years now, and with VMware SD-WAN almost the same time. And I've helped a lot of enterprises and service providers help design and architect their SD-WAN network and change their WAN architecture from traditional to more modern and agile.
Thanks, Tej.
Yep.
Yes, hi. My name is Karthik Ananthakrishnan, and I'm a product manager in Azure Networking. We are keenly focused on capabilities that we are bringing at the edge, and I'm excited to be on this webinar with VeloCloud, where VMware VeloCloud, where we are unlocking new capabilities for customers. Back to you, Josh.
Thanks, guys. So Tej, actually, over to you.
All right. We'll start off with agenda. So, just to let you know what the flow of the webinar would be. So we'll delve into, the SD-WAN architecture. So just to understand how VMware SD-WAN architecture works, what are the different components to it, because it's necessary to know how these components work together and then how they help connect and build that connectivity from SD-WAN into Azure or SaaS applications. And after that, we'll go into different Azure connectivity solutions, how we connect to virtual WAN, virtual routers, which was recently announced at Ignite. And then, how we build connectivity through our AVS called Azure VMware Solutions. Then we'll see the Microsoft 365 connectivity with VMware SD-WAN and how we help improve that, the performance of this application using our own proprietary MPO protocols. And lastly, we'll end with the Azure Edge Zones, and how SD-WAN, VMware SD-WAN and Microsoft working together to bring the Azure Edge Zone story together. All right, so VMware SD-WAN has, overall three different components that work together to build the whole solution, right? On the top, you see is VMware SD-WAN Orchestrator. That's the management plane of the solution. That's where customers log in and see their entire enterprise network architecture and see all the branch locations, different ISP links, monitoring, troubleshooting, everything goes into the orchestrator. It's a multi-tenant orchestrator hosted by VMware SD-WAN, and it's and customers don't have to manage or have to do anything with the orchestrator. There are other models with the service provider or on-prem where the architecture is slightly different, but we'll stick to our most common architecture. And orchestrator is also where we build all the integrations with any third-party vendors. For example, virtual WAN integration and automation goes through our orchestrator. Any other integration such as ServiceNow or Splunk, any other integration or API integration also goes through our orchestrator. Then the second component, if you see, is on the internet bubble. There's two cloud gateways. So the cloud gateways is very unique to VMware SD-WAN architecture, right? So because these cloud gateways are hosted all across the world at a very strategically located places. They serve two primary purposes. The first one, is to get that on-ramp for all the branch locations and home users to get that good connectivity from the branch to SaaS applications as well as infrastructure as a service platforms. How they provide that is these are multi-tenant gateways and they are connected or placed very close to most of the SaaS applications, and also have peering, for example, peering with RingCentral, peering with Microsoft. So they're direct peerings with these, SaaS application providers and infrastructure providers. And branch locations, when they have, let's say, they have two internet connections, they will connect to their closest cloud gateway and use that cloud gateway to send any kind of SaaS application traffic. What that provides is, it provides a better underlying connectivity than your underlay transport, for example, internet provides, because those two links going to the cloud gateway has a SD-WAN DMPO tunnels on it. And we kind of plug that link into one single link. And we always know which link is better to send that traffic on. And if there's any issue with the link, the next packet moves to the second link, right? So there's no impact to voice or video or any implication to TCP, because even if there is any kind of packet drop happening on the internet, we will do the remediations to actually, do a duplicating the packets or ending TCP NAC. So that provides a managed solution to on-ramp, which customers don't have to manage as such. Otherwise, customers have to put their own edge-to-end edges, maybe in IaaS providers. But for SaaS, there is no such solution as this. The second function of the cloud gateways is, control plane to help build the tunnels all across for the branch locations to build tunnels within each other, or also to connect to, data center edges. So this is where, one of the integrations that happened with Microsoft is related to virtual WAN that we'll talk about in incoming slides. And the last one is the SD-WAN edges that you see sitting on the branch locations. SD-WAN edges is, could be hardware or it could be a VNF running on, for example, on private edge zones, or any other third-party x86 architecture box. So the SD-WAN edges provide all the necessary functions that today's, let's say, routers provide, right? So along with that, we have our own proprietary protocols like DMPO to actually build those automatic tunnels and provide the QoS qualities and stuff. Also, we have on the SD-WAN edges, we have ENI, so edge network intelligence. Any packet going through the SD-WAN edges is analyzed, and we build the baseline of all the applications going through the edges. And we always identify any kind of anomalies or enterprise application performances analytics. And both SD-WAN edges and gateways, they all talk to the orchestrators as a management plane. So that's the overview of our architecture, 3 different components: SD-WAN edge, gateways, and orchestrators. And we'll see how these work together to build that cloud connectivity from SD-WAN to Microsoft. So before we begin into how VMware SD-WAN and Microsoft are working together for different connectivity solutions, just want to get a baseline of what are the different solutions that Microsoft provides for their native connectivity to the cloud, right? So the first one is ExpressRoute, which is the oldest solution, and it's a private line connection to that goes into customers' data centers or provided through ISPs through their colo locations, etc. The second is Azure Virtual WAN, which we have a very deep integration with. And the third one is IPsec to Virtual Network Gateway, which is a very standard solution running BGP or IPsec to the VNGs. We'll not really talk about this solution because it's very basic, and you can build IPsec tunnel from our edges, or you can build it from our gateways. The last solution is virtual routers, which is recently announced as coming soon at Ignite. We're working very closely with Microsoft and launching this solution where you don't have to worry about UDRs anymore, and where customers have a shared network or shared VNets architectures. All right, so how VMware SD-WAN connects to Azure Virtual WAN, right? So we today have 3 different ways to connect to Azure Virtual WAN. The first one, if you see on the list, is via our cloud-hosted gateways. which this is very unique to our architecture. The way this works is customer logs into our orchestrator, plugs in its, registers our orchestrator as a certified application on Azure directory so that our orchestrator can call in and find out all the virtual WAN hubs in the customer subscription. And from there, they can go ahead and configure a virtual WAN connection from our cloud-hosted gateways. Since these gateways are mostly in colo locations, the last mile from a gateway to virtual WAN on Microsoft is less than 5 milliseconds. So what you're getting through this solution is a fully managed solution because we manage the gateways. Azure Virtual WAN is managed by Microsoft. So SD-WAN edges or branch locations, it could be, let's say you have 10 branch locations. They all could connect to the same cloud gateway. And from the cloud gateway, you have this IPsec tunnel running to virtual WAN. And you can run PGP on it and exchange those routes that way, right? So this is an easy one-click solution from a gateway connection to virtual WAN. And this also gives you a last mile protection. You could have multiple links on your SD-WAN edge. Let's say you have 3 different links, all going to a cloud gateway. All those 3 links is clubbed as one link, and we monitor the links. And if there's one big flow going to Azure Virtual WAN, we can actually send that traffic over all 3 links because we do the per packet analysis and per packet forwarding. So we send that traffic over to the cloud gateway, and from there, right on to IPsec tunnel to virtual WAN. This also is a built-in redundancy because we build these IPsec tunnels from multiple cloud gateways to virtual WAN, so you will always have active and standby gateways. The second solution in this is where you have virtual edge sitting right in the customer VNet. This is something which is managed by the customer. So in this case, customers can have 1, 2, or multiple edges deployed in the VNet, and then from there they can build IPsec tunnel directly to the virtual WAN. And virtual WAN could have a VNet peering so that traffic goes from edges to virtual WAN to all the peering, all the different VNets that appeared with that virtual WAN. What the difference between the first solution and the second solution is, in the second one you have SD-WAN overlay going from branch locations all the way into the VNet. In the top solution, you have SD-WAN going all the way out to a gateways and then writing that transit link. But the first one is fully managed solution, and the second one where customer has to manage the edges deployed in the VNet. The last solution is the very basic one where you could build an IPsec tunnel directly from your edge. This negates all the benefits that you would get running a DMPO protocol over these tunnels, because these tunnels are very high performance tunnels which always continuously measure and remediate the traffic, and also provide you QoS over the internet links. So now let's dig into a little deeper into how virtual WAN and our cloud gateway solution would look like, right? So let's say if there's an enterprise which has 4 different regions. In that case, let's say for US East region, you could build an IPsec tunnel or multiple IPsec tunnels from a cloud-hosted gateway, which is also located in US East. And the branch locations or home users sitting in that location will connect to that gateway via their public internet links. Because of these links are running DMPO, so these are highly reliable internet links because any kind of issues will be remediated by your edges. And from there, you can write into Azure Virtual WAN and go and access any VNets or any resources or workloads sitting in US each region. And you can also ride the backbone to go to other regions if you want to access other regions. Similarly, for other regions, you could have a different cloud gateway in that specific region building that IPsec tunnel, right? And all these IPsec tunnels, you can exchange routes via static routes and coming soon the PGP from a gateway directly to these Azure Virtual WAN hubs. You could also, do a mix and match. You could have some regions where you could use using a cloud gateways, and other regions where you could just put our edge directly in the customer VNet and build that connectivity through our virtual edges, or maybe you need a very high throughput. So in that case, you could deploy a cluster of our edges in the VNet connecting to the virtual WAN. So this way you could leverage a fully managed solution by VMware and Microsoft from your branch locations to the VNet in that same region or across the regions using Azure's backbone. Right, so that was virtual WAN, and we're also working with Microsoft on SD-WAN in virtual WAN, so where customers could be able to deploy virtual WAN and SD-WAN within the Microsoft VNet and do that native peering. So that's also a solution coming soon. The next up is virtual routers, which is a very different architecture from virtual WAN. Virtual router solution is for customers who would like to manage their entire routing by themselves. In this architecture, you have virtual routers sitting in the transit VNet, and you could have other services sitting in that same VNet, and you can deploy our virtual edges in the transit VNet and peer with virtual routers. What virtual routers, helps you provide a service where you no longer have to go into each VNet and change the UDR routing or point to another next hop if one edge goes down. So all that UDR route manipulation is taken care by.
Sorry, folks. Appears like we may have just lost Tej for a second there. Tej, are you still on the line?
I'm sorry?
Oh, sorry, Tej. We lost you there for a second.
Oh.
Could you just go back maybe 30 seconds? Thank you.
Sure. All right. So just to understand how the end-to-end connectivity in this solution would look like. So you have branch.
I think Tej is probably having internet issues.
Karthik, should we go down to the edge zones, your section, whilst we're waiting for Tej to rejoin?
Sure. Let me do that, Josh, when as Tej figures the connectivity out. So,
yeah. Let me just skip a few slides here, and we can have Tej recover those. Apologies, folks.
Sure.
Just skipping through them now.
Let me go to the section. A few more slides here.
For some reason, the slides are being changed automatically.
Hey, Tej, we keep on losing your connection.
So I was going to the edge zone slide stage to see if you want to figure out the internet connectivity, and then you can come back to the rest of the stuff.
Okay.
Oh, it's better. I mean, let's try it one more time, Tej, and if it drops, we'll go back to the.
Okay. Go for it, Tej. You can press it.
Yeah. Okay. All right. So. Let me know which slide you guys see, okay?
Yeah, we can see VWAN. That's right. That's where you were. Yeah, on VRIP.
Okay. All right. Great. Okay. So just to end with this, right? So you could also, some of the customers are also leveraging their private links from the data center, the express route gateway connected to virtual routers. They could use that as another backup link or active link with their SD-WAN, public internet, and express route. So now from your data center or branch location, you could connect directly through the internet as well as through express route gateway as the two active backup links. So another solution that that we recently announced is Azure VMware Solution 2.0. The architecture of AVS is that you have a full VMware SD-WAN stack running in Microsoft Azure, and where the customers connect to it after they have transformed their their workloads from on-prem DC to AVS is these branch locations still come back to customer DC, and from there write the express route and access AVS, right? So even if the customers have moved their workloads from data center to Microsoft Azure, the traffic flow hasn't changed, right? So the traffic flow would still go to DCs, and then and that will add the extra latency and might even impact the application performance after moving to Microsoft Azure AVS solution. So where this, where this architecture with VMware SD-WAN would look like is, you could have these branch locations connect directly from the branches directly into Microsoft Azure using the virtual router solution. In that case, you have these branch locations which will go directly from the internet into the cluster of edges, and via the virtual routers send that traffic to AVS, right? So in this case, now you're eliminating any kind of backhaul. You reduce the latency, and you get actually a much better performance when you're using AVS, in Microsoft Azure. All right, so let's go into how we work with Microsoft 365, and what are the different solutions that we have, for this connectivity. So a little bit of background on Microsoft 365. This is the slide right out of Ignite event, where Microsoft cares about how customers design their enterprise solution or enterprise network architecture, because the way the customer design their network architecture impacts what will be the performance of Microsoft 365 when they get to when they move that or use that as SaaS as a service, because Microsoft is doing a lot of optimization in their first mile within the Microsoft cloud, but where they need help from from enterprises and from SD-WAN vendors is the last mile and first mile, because they really want their traffic to get directly into, or as soon as possible, into Microsoft cloud to get that optimal Microsoft 365 SaaS performance, right? And the networking connectivity is so important to Microsoft 365 is that they have created this, a network connectivity principle called NPP program, which certifies vendors who comply with all the principles of connectivity to M365. And we are one of the vendors being certified, for this program. The way this works is, the first thing is to identify the Microsoft 365 traffic on the first packet that we do, because we integrate directly with Microsoft 365 RF feed. So anytime there's any upload, any change in IP or URL, we automatically detect it and gets pushed to all the edges or all the branch locations for the customer. So there is no lag in the IPs and URLs that Microsoft published, and that the customer is running on-prem on their edges. The next is, first you detect the application, and then you actually, route it either directly to a cloud gateway, and also make sure that it gets its fair share of bandwidth that we do with our own QoS policies on those branch locations. So next up is, how do we connect, right? So what are our proposed solution for Microsoft 365? If you look on the left-hand side, let's say you have a branch location, and you have two internet links going out through that branch location, right? The connectivity will work the way it will work is you have a traffic coming in on the branch, gets detected as M365. We will see that, okay, out of ISP1 and ISP2, which is the best link to send the traffic to closest cloud gateway, because using a cloud gateway, you get that last mile optimization and also the best connectivity to, as close to the service front doors of Microsoft 365. So let's say in this case, we say ISP1 is a better link at that point of time because we measure the link quality by using real packets going into to the internet. In this case, let's say we see ISP1, and from a gateway, it's a direct peering at most of the top locations, direct peering with Microsoft, and we send that traffic directly into the Microsoft cloud. So similarly, let's say if you have a bigger, a big file download or upload, we might use ISP1 and ISP2 both simultaneously because of our per packet forwarding, and upload that traffic or download that traffic to through our gateways into Microsoft Cloud. So this because this is a distributed architecture, each branch location will connected to their own closest cloud gateway and to their different service front doors based on the geographical location. So you could have this, distributed all across the world, where different cloud gateways will connect to different service front doors. So next up is, we want to see first, some tests for the, for the home users to see how connectivity through VMware SD-WAN via the internet through our cloud gateways looks like, right? So we did some testing to show the performance differences if there's internet, a bad internet link or acting up internet link, right, throughout the day. So if you look at this test, with the topology of this set looks like you have an SD-WAN edge. You have two users, one user sitting behind an SD-WAN edge, and that SD-WAN edge has the CMPO tunnels built to the closest cloud gateway. And you have another user which is sitting on the same internet link, but no SD-WAN. They connect directly to the internet. And in this specific case, you're Microsoft Teams, and we are accessing a UDP stream to transport relay. And if you notice, if there's we introduced, let's say, a 5% packet loss bidirectional, and if you notice for the user that's going over SD-WAN, we almost remediated entire packet loss. So you barely see any kind of packet loss through our packet duplication technology. So that user never experiences any issue compared to the user going directly is experiencing almost 5 to 10% of packet loss. And similarly, the jitter correction, if you see the jitter, because we do jitter buffering, the user sitting behind SD-WAN edge does not experiencing a huge jitter variance compared to a user sitting directly on the internet. And similarly, we did the test, something with the other OneDrive and SharePoint, just to see the download and upload and access, speed for it. If you notice here, because even if you have 1 to 2% packet loss, it impacts a lot on the TCP performance of the application. And in this case, a user sitting behind SD-WAN had almost double, or not double, I would say, almost 5 times the throughput than user, sitting directly on the internet and experiencing the same kind of packet loss. And lastly, we want to show you like a SharePoint, throughput test. If we just introduced a 2% packet loss, and then we, downloaded files from SharePoint, and you can clearly see what the difference that going through a cloud gateways compared to going direct, would have an impact on the SharePoint throughput. It's almost again the 5 times difference. So with that, I'll hand it over to Karthik for our Azure Edge Zones and how VMware and Azure Edge Zones are working together to build that SD-WAN fabric.
Thank you, Tej. Hi. Tej talked about a lot of capabilities on how we are really bringing different capabilities with VMware SD-WAN and with the public Azure. So I want to talk a lot about how we are bringing the VMware SD-WAN Edge capabilities onto the customer premises with some of the Azure capabilities and some of the new exciting stuff we are doing in this space. But before I go into the integration aspects of it, I just wanted to take a step back and talk about the different capabilities that my Azure is announcing with respect to focusing on technologies like 5G and how we are enabling network functions to run on the customer's edge, basically. So if you see this slide, we have Azure regions that is growing very fast. We have 60 plus regions at this point. Now, what we announced back in March is a set of capabilities catering to technologies like edge computing and 5G. We announced Azure Edge Zones and Azure Edge Zones with carriers. So Tej talked about the SD-WAN, the VMware SD-WAN gateway, the multi-tenant gateway. Now you can think about a multi-tenant Azure which is running in a metro or it is running in a telco's premises with edge zones with carriers. Now you can run workloads like the SD-WAN gateway on this infrastructure. Basically what we are trying to do here is get compute, storage, and networking closer to the enterprises and any applications that are latency sensitive from a 5G network standpoint. We want to bring it closer to the enterprise customer by enabling edge zones and edge zones with carriers. Now a lot of this talk is centered around Azure Private Edge Zones, where we are really keenly focused on the enterprises taking advantage of a form factor which is based on Azure Stack Edge, and enterprises looking into scenarios like private wireless networks and running network functions at the edge. So what we have done is basically with private edge zones, we have used an existing Azure service, which is the Azure Stack Edge, and we have built new capabilities on it so that you can now run a virtualized network functions like a mobile packet core, the RAN, the access point and the RAN of a wireless network, and then you can run a VeloCloud, a VMware SD-WAN Edge on it as well, basically. So essentially, think about this as a platform on which you can run both applications, VM or container-based applications, and you can run also network functions like the SD-WAN Edge on this platform. So essentially, you now have a platform on which you can run both network functions and applications, and it is completely cloud managed. So as we have been working on this, what we have done on the Azure side is basically we have built a strong ecosystem of partners like VMware, where you should now be able to go into Azure and with the ecosystem of OEM partners and then the SIs and the telco partners, you should be able to go and deploy a private wireless network and also run other network functions and also run your edge computing application on this platform and manage everything from the cloud. So really a new set of exciting capabilities for the enterprise IT to look into scenarios like private wireless networks. And if they cannot manage this on their own because the whole technology is very complex and there are multiple components at the play, you can, we are building an ecosystem of SIs who can build end-to-end solutions on top of it. And we are working also with the telco partners who can put together a solution, vertically integrated solution for private edge zones. Now, the capabilities that we are bringing with private edge zones is based on the Azure Stack Edge Pro that we made generally available at Ignite in September. So the Azure Stack Edge Pro has a GPU capability for if you want to run edge computing applications that needs to perform the GPU video inferencing at the edge, or you want to do video analytics and other scenarios, you can now do that. Specifically catering to the running network functions at the edge, what we have done is basically we have enabled fast networking on ports 5 and 6, and that is where we have some of the opportunities to innovate with VMware to provide the best performance for network functions running on this platform. So the Azure Stack Edge itself, which is what the private edge zones capabilities are provided, contains native support for an IoT edge. You have an IoT edge runtime. You can also run Kubernetes workloads, or if you have your VM-based applications, you can run them on the edge. So essentially, think about an enterprise branch office where you can run a lot of edge computing applications on this platform, and you can also take advantage of the VMware SD-WAN edge that is running side by side with respect to the edge computing applications for connectivity to Azure. So because a lot of applications are moving towards containerized, we are bringing in a lot of capabilities for orchestrating containerized workloads onto this Azure Stack Edge. So you can take advantage of a native Kubernetes environment that is provided as a managed service on the device, where we take care of the software updates and anything that we need to do for the underlying services that is running on the device. You just have to point to your GitOps, and you can download your container part from the container registry. You can also use the IoT Edge runtime that is running on the device to be able to bring in a lot of Azure services to the device and run it as an edge compute application. So think about like spatial analysis type of modules with respect to the situation that's playing out with pandemic. If you want to do like people counting type of applications, or if you want to do social distancing apps, you can now take advantage of some of the custom vision and computer vision modules from Azure, and you can run it on the edge using GPU inferencing. You also can perform services like video analytics at the edge, which is a packaged module from Azure that you can run it on it. And for anything that you need to stream the data to Azure and you want an optimized network connectivity, you can use the VMware SD-WAN Edge and connect it that way to Azure. Tej talked about how you can connect it to virtual WAN hub or to a virtual network. You can take advantage of those type of topologies. So really kind of bringing it together. Now, if you are an enterprise looking into alternative scenarios for Wi-Fi, where you are looking into CBRS-based private wireless network, what this private edge zone based on Azure Stack Edge brings you is a platform on which you can run specialized network functions like the packet core, the mobile core of a network that gets completely deployed on the device, and it operates locally. You can now run the VMware SD-WAN Edge side by side with respect to the packet core network function. And you can also co-locate your edge computing applications, GPU-based edge computing applications running on the same platform. So essentially for this entire topology, the entire traffic stays locally on your network and all the data processing happens locally. The only connectivity to the cloud is an outbound connectivity for management purposes, both for the SD-WAN Edge as well as for the other services running on the device. So with that, here is the exciting work that we are doing with VMware SD-WAN. Tej talked a lot about the different capabilities that VMware is working with in terms of integrating with the virtual WAN, also running the VMware SD-WAN Edge in an Azure virtual network, and giving you an end-to-end solution. Now we are extending these capabilities where the VMware SD-WAN Edge is now packaged as a part of the private edge zone solution. So you can now have a click and deploy experience of the VMware SD-WAN Edge onto the Azure Stack Edge that is running in your on-prem environment. So you can get an Azure Stack Edge, and if you have scenarios where you want to run edge computing applications, or you want to build a private wireless network, and you want to complement that with a VMware SD-WAN Edge, it is now going to be available as one of the managed apps in our marketplace, so that you get the same experience of click and deploy of the VMware SD-WAN Edge, and it gets connected to the orchestrator, and you get a complete cloud-managed experience for the end-to-end deployment. We are also looking into how we can run the VMware SD-WAN gateway on Azure Edge Zones and Edge Zones with Carrier, which is a multi-tenant infrastructure, so that we can optimize the traffic from the customer branch office all the way into Azure. So with that, what I want to do is, in the interest of time, I quickly want to show you a demo that we recorded for the VMworld event, where I want to show you how easy it is for an enterprise customer to deploy a VMware SD-WAN Edge on the private edge zones infrastructure. So let me switch to my screen to share the demo. So this is a demo that we recorded for an event that we did. So here, let me just go to the start of the demo. So in this demo setup here, I have an Azure Stack Edge that is running in my enterprise premises. And this device is already connected to the cloud, and it is in the online state. Let me just move this window here. And now, if you see this, the device is connected and it is online. So just to show the different ports that we have connected, to connect to the VMware SD-WAN Edge, we have connected the port 2 for the management purposes. The port 5 and the port 6 are connected to the LAN and the WAN of the network, basically. So once the device is racked and stacked and the physical network connectivity is done, you can now completely cloud manage this device from the Azure portal. So the device is connected to the cloud, and we are able to access the device from the management port. You just have to open your corporate firewalls for outbound access for the services to the cloud, basically. So once this is set up, what you can do now is the work that we have done with VMware is that we have packaged the VMware as a SKU in the Azure marketplace. So what you can now do is basically go into your Azure Stack Edge device and go into this resource, which is the Azure Network Function Manager Virtual Network Function Blade. And on this, you just pick a SKU of VMware SD-WAN, and you specify your custom IP configurations that is relevant for your enterprise network. And you just provide your configurations and your configurations. Then you have a complete click and deploy experience for this managed app that gets deployed on the Azure Stack Edge. And once the SD-WAN Edge is deployed, it becomes a complete cloud managed experience. So Tej talked about the VeloCloud Orchestrator. You can now go into the VCO, and from here you can completely manage the SD-WAN Edge, and you can do advanced configurations and everything from this. So we have made it very easy for, just like how you go and deploy a VMware SD-WAN Edge into a virtual WAN, you can now do the same thing with private edge zones. And for your enterprise deployments, if you are using Azure Stack Edge, or if you're thinking about edge computing applications or private wireless networks, we are now opening more possibilities for you to get the VMware SD-WAN Edge and get the same optimum SD-WAN solution to your branch offices. With that, let me go back to my presentation slides. And that's the end of the demo. And thank you for participating in this webinar. I will hand it back to Josh for the next steps.
Thanks, guys. Really appreciate that. So we have a couple of questions coming in, and we have some time to answer them. So first one, Tej, directed towards you. So you mentioned some tests with SharePoint. So are you able to detect sub-services in M365, such as SharePoint, Word, or Outlook, and provide different policies?
Yeah, thanks, Josh. Yes, we can. So within Office 365, we do detect sub-services as well, and you could build different business policies based on that. And we also have a different applications for Microsoft Teams and Skype, right? So you could have for Teams, because it's a very latency sensitive and it's it's a VoIP-based solution, you could actually configure a totally different policy, put it in a different QoS class, so that it gets its fair share, and the voice calls does not impact, doesn't get impacted if there is any other thing going over the same links, right? So yes, we do detect the sub-services, and different policies could be configured for that.
Thank you, Tej. Karthik, one for you. So this one's around private edge zones and integration, and the question is around its uniqueness. So can you maybe give us a few what's unique about that private edge zone integration?
Sure, thanks, Josh. So what we are seeing is a lot of customers looking at a platform where they are going to run edge computing applications and network functions, and really a lot of interest in kind of completely providing a cloud managed solution, a single pane of management for all of these deployments. So what we are enabling with private edge zones and the work that we have been doing with VMware SD-WAN is, if you are a customer who is looking into the edge and a smaller form factor that can go into your branch offices and your enterprise premises, you can now look into private edge zones based on Azure Stack Edge, and you can run your edge computing applications which are natively managed on cloud, and you can also now click and deploy your network functions and run it on the edge, basically. So that's the value prop of private edge zones, where you can run both network functions as well as applications on the same platform, and it provides you an end-to-end cloud managed capability.
Perfect. Thank you. Tej, another one for you on here. So what happens if the POP from Office or Microsoft is too far from customer and Velo gateways, for example, in LATAM?
So yeah, so for we do have a gateway in Sao Paulo, but that's a valid question, right? So as with our SASE POP strategy, we recently announced a new a solution called SASE, and we are actually expanding our POP locations pretty significantly with that with that strategy. And just in case, maybe let's say somewhere in Indonesia or Thailand, where if you don't have a closest gateway, the customer always has an option to send it out, direct. But you also have to evaluate that if because 5 to 10 second millisecond latency does not impact the performance as much compared to connections which are unstable and could have a random packet loss or a random increased jitter, right? So the trade-off between 5 to 10 millisecond latency to sending it out direct and relying on your internet provider to always get you that best connectivity. So it's always something that customers have to see, because we believe that adding 5 to 10 millisecond latency but sending it over the SD-WAN tunnels, which will always be monitoring multiple links, and then also doing a remediation in case those links go bad, and sending the next packet to a better link, so that your application always goes on the best link. So those added benefits, I think, outweighs, in case of the locations where you might not have a very close proximity.
Thanks, Tej. And then I'm seeing a couple of questions, actually. I'm going to group these under a theme. I'm seeing like work from home, SD-WAN Edge at home, because obviously with the current state, obviously with COVID-19, a lot of people are not in branches. So, are there benefits tied to having an SD-WAN Edge at home, and with the theme of the Microsoft topic as well?
Yeah, sure, right. So bringing up an SD-WAN Edge is really simple, right? That's one of the key aspects of SD-WAN is you plug in an internet link and you boom, you activate it, and it connects to your corporate network. And second is even for home users, right? With the home users, we have built multiple solutions where you could, let's say in the home you're competing with your Xbox, with Netflix, and you're also taking Zoom calls and or Teams calls, and you need to make sure that your business applications work better over and get prioritized over other home user traffic. That could be easily done with our with a Goinger orchestrator and changing the policies to making sure that all your critical applications get that fair share of your internet bandwidth. And also, if your internet is going bad, then you can actually do the remediations, which would help improve the performance of all the applications that you're using related to business. So, and we also introduced a new segment called private segment, where all the traffic which is that does not need to go to orchestrator or does not need that visibility and analytics will stay local, right? So home users are able to maintain their privacy related to the home traffic and only send the traffic which is useful or which is business related to the orchestrator process and policy adjustment.
Excellent. Thank you, Tej. So it looks like the questions have now, that's pretty much it for questions that have all come in. So thank you everyone for attending today's webinar. I will be uploading a copy of the slides after this session. So please do feel free to come back and view those. Thanks again to our presenters, Tej and Karthik, and have a great rest of your day, everyone. Thanks ever so much for attending.
Thank you.
Thank you.